All right, so here on top are the three transformations we're going to talk about in this unit. You probably have heard of them before. The first one's a reflection, second one's a rotation, and the third one's a translation. A reflection is a flip, okay, a flip or a mirror image over a line, and it has to be a line. So if you notice, here is our line that they're flipping over, okay. What they do is that the distance C is from that line is the same distance C prime is over the line, and the same thing with A. The distance from A to the line of reflection is the same from the line of reflection to the new point. Notice they labeled it with a prime. Okay, and the same thing with the last coordinate. Whatever distance B is from the line of reflection will be the same distance B prime is over the line of reflection. Okay, so a figure is flipped over a line. Okay, a rotation is a turn. And when you turn something, you turn it around a point, like a pivot point. Okay? And so there is our point that they're turning this shape around. Whatever the distance from J to that point is going to remain the same distance from the point to J prime. And the same thing with K and K prime, L and L prime. Okay? So this is turned around a fixed point. Okay? And you turn it a number of degrees. And you can turn it clockwise or you can turn it counterclockwise, which we'll talk about. Okay. The last one is a translation. They call this a slide. Okay. We will slide left or right and then up or down. Okay. So it looks like the slide is diagonal, but really what we would say is that it went to the left and then to the right, and then it went down. Okay. And that's how we get that diagonal slide. All right. So a figure is slid into a new position. Okay. No turning, no flipping. All right. And that's a translation. So a translation is a slide. A rotation is a turn. A reflection, we said, is a flip. All right, so in this next part, we're going to go ahead and identify what they're doing to these pictures, and we're going to try to be as precise as possible, okay, especially when we're doing them on a graph. All right, sometimes it's not possible to be as specific, especially when you're not on a grid like these first couple pictures. All right, so in this first one, you guys can see that this is my original triangle. He doesn't have any primes on him. Okay, and then this is my new triangle with the primes on it. And so what happened to this? Did it flip? Did it turn? Or did it just slide? And hopefully you guys are saying that this just slid up. So G slid up this amount, F slid up the same amount, H slid up the same amount. Okay, so this is a translation. The only thing we can be specific about it is that it was a slide up, okay, so that it went up. However, we don't know how many units it slid up. We're not on a graph, so we can't count. Okay. In number 2, again, you can see that this is my original triangle, okay, or my pre-image, and this is the image of it. Okay. And if you can see, it didn't just slide, right? It didn't turn. What happened is that it flipped over some sort of line that goes right in between here. Okay, and so they took the blue triangle and they flipped it over the line. And so because it's a flip or a mirror image, we're going to call this one a reflection. Okay, and we could say over some sort of vertical line. Okay, but again, we're not on a graph, so we can't be as specific as we would like. Okay. In the number 3 here, we can see that this is our original rectangle. And this is our new rectangle. Okay? And if you take a look at the letters on there, and you can see A matches up with A prime in order for D to match up with D prime, C to match up with C prime, and B to match up with B prime. I believe you would have had to take this rectangle that's blue and either turn it that way or turn it several times this way. All right. And so this is a turn, which is a rotation. Okay. It's probably maybe a 90 degrees this way. Or you could say that it is a rotation of 270 degrees this way. Okay. This way, when you turn something, is the same way the clock goes. And so this would be clockwise. And this is the opposite the way the clock goes. So this would be counterclockwise. All right. The rotations that we will do will always go counterclockwise, okay, so that they can stay positive degree rotation. So this would be a positive 270 degree, whereas this one would be a negative 90 degree when you go clockwise. Okay. All right. So here on the bottom, we can be a little bit more specific since we're now on a graph. So in number 4, what do we think that this looks like? Well, this is our original triangle here. And this is our image. Okay? And if you can see that triangle, that blue one to get onto that red one would have to be flipped over that line, which is the x-axis. And so we're going to go ahead and say that this is a reflection over the x-axis. Okay. And eventually, when we spend a day on each of our transformations, we're going to learn how to abbreviate that so we don't have to write it out like that every time. And so reflections are going to be abbreviated with a lowercase r and what we call a little subscript. Subscript is writing below the line of writing. And so down here, we put a little x-axis. And that's how that would be abbreviated. So you can see how much time it would save you from writing it. Okay. In the next picture, this is my original rectangle, and this is my image, and we can see what happened here. Okay, so did it flip? Did it slide? Or did it turn? And hopefully you guys can see that it definitely turned. And again, we try to go the same way the quadrants go, which is counterclockwise. So we would have had to turn it looks like that amount of times. Okay. If you think about how it would look, let's see. Okay. Since it's a turn, we're going to go ahead and say that this is a rotation. And if we turn it, a little sketch, but our rectangle would be standing up, then our rectangle would be turned and laying down, and then we would turn it one more time to end up on the red one. And so that would be a 90 degree to get here, a 180 to get here, and then a 270 degree to get here. Okay, turns are in quarter turns, which is 90 degrees. So 390s would be 270 degrees. Okay. We also like to say what we rotated it around. And in this class, we're going to always rotate around the origin. That's our pivot point. So it's a rotation. And we can go ahead and say around the origin of 270 degrees. Okay. If we were going to abbreviate that, like we will learn, rotations are actually capital R because lowercase r are reflections. What you rotate around, which is the origin, is written as a O for the subscript, and then a comma, and then the number of degrees, which is 270 degrees. Okay. In our last picture, it looks like this triangle here is my original, and that this one is my new one. Okay, and you can see that the triangles are facing the same direction. They didn't turn, they didn't flip, and so this is what they're going to call a slide, which is called a translation. Because we're on the graph, we can give the movement of the translation. We always go left or right first, which makes sense because the x coordinate, which goes left or right, comes first. So we give that movement first. All right. So in order for this Q to line up with that Q prime, we're going to have to slide it. It looks like a little bit to the left. So I would say 1 unit. Okay, so we'll say, I'm sorry, right. So we have to slide it to the right. So we're going to say right 1. And then it looks like how many do we have to slide it up? 1, 2, 3. And that Q will fall on that Q prime. And so we're going to go ahead and say up 3. All right, and each point should move the same. So if we move this guy over 1 and up 1, 2, 3, notice P will fall on P prime. If I take R, slide him 1 unit to the left, to the right, okay, and up 1, 2, 3, he ends up on R prime. All right, so each point slides exactly the same pattern that one set of points is. Okay. If we're going to go ahead and abbreviate, we use a capital T for translation. And to the right one is a positive 1. So we put that as the first number in the subscript. And then we put a comma. And up 3 is a positive 3. And so there's our translation. Okay. All right. We got one last question. Down here in number 7, it says, which of the following transformations maps triangle ABCD, which is this rectangle, which is this rectangle right here, onto rectangle KLMN. And so notice they didn't use primes, so that's a little bit tricky to know which one comes first. So it was important that we read and we understood. One more thing that we can do is we can play something called the letter game when they don't use primes. Because A came first and K came first, A is going to get mapped onto K. Okay. B comes second, L comes second, B is going to get mapped on to L. Okay. C comes third, M comes third, C is going to get mapped on to M, and D is the last letter, N is the last letter, D is going to get mapped onto N. All right. So basically, we're trying to figure out how A in the blue rectangle is going to get to become K in the red rectangle. Okay. Likewise, B's image is going to be L. Okay. C is going to become M. And last but not least, N is going to become D, or D is going to become N. Okay. But you can see how the points match up. So it does look like a turn. Okay. It does look like a rotation at first. But if I rotate the blue rectangle, I don't think the A in the blue rectangle would turn to fall onto K in the red one. It does, but all the other points wouldn't line up. So what you have to realize is that this isn't a rotation. Okay. Also, it's not a slide because the rectangles aren't facing in the same direction. And so this is a reflection. Now, what line are they flipping it over? They're flipping it over the x-axis. Okay, so A will flip and become K. Okay, B is 1, 2, 3, 4, 5 units to the line of reflection, and so that's why L is 5 units below the line of reflection. Okay. C is 1 unit above the line of reflection, so it's going to flip over the line of reflection and go 1 unit below it. And the same thing with N. N is 3 units above the line of reflection, so when it flips over and becomes D, okay, or D becomes N, okay, technically it goes that way, they're flipping over every single point is flipping over the x-axis and becoming the other point, okay? And so this is a reflection over the x-axis. But if you looked fast, you would say that that rectangle is turning. But that's why it's important to pay attention to the letters. What letter goes with what letter, okay? And it's tricky when they don't use primes and they use a completely different set of 4 letters. All right. Hope that helps, guys. And go ahead and do your homework. And I will see you guys on the next day of notes.